Important properties of matrices. If you have three non-zero matrices, it's possible that AB is not the same as BA. Versus what you learned in algebra. In algebra, you learned that x times y is equal to y times x, but it's not the same in matrix world. So if you multiply two matrices together, the order of multiplication is important. If you have two matrices and their multiplication is equal to 0, it doesn't imply that one of them is going to be 0. For example, you have matrix A, 1, 2, 3, 6, non-zero matrix. You also have another matrix like B, -4, 6, 2, and -3. If you do the multiplication A times B, it is just basically taking the first row, multiplying that by the first column. So as you can see, you have 1 times -4 plus 2 times 2, which is 0. You can continue this process and check the rest of the entries. The first row multiplied by the second column, it gives you 1 times 6 minus 6, which is again 0. And then you can move on to the next row, 3 and 6 multiplied by the first column and multiplied by the second column to find these two entries, which are going to be 0. So as you can see, you have two non-zero matrices, but their multiplication is 0. Versus what you learn in algebra. In algebra, if you have the multiplication of two variables, two algebraic statements equal to 0, then for sure you can conclude that one of them is equal to 0. But it's not the same in algebra or matrices. Another interesting example is we don't have cancellation when it comes to matrices. If AC is equal to BC, you cannot just say that, hey, I can cancel out C and C and A is equal to B or C is 0. It's not correct in general in matrix algebra. For example, consider these three matrices. A is a non-zero matrix. It is -3, 3, 11, -3. And also B is another matrix, -1, 2, 3, and 1. You have matrix C with entries 1, 3, 2, and 6. If you do the multiplication of A and C, the multiplication of B and C, you basically create two matrices which are the same. They have the same entries. Here, if you multiply -3 and 3 by the first column of C, what you get? You get -3 times 1, which is -3, plus 3 times 2, which is 6. Gives you 3 back here. Continue the process. You can find the rest of the entries. Then you can move on and multiply B and C together. So if you multiply B and C, let me change the color here. This is basically the multiplication or the dot product, as you remember, of the first row and the first column. -1 times 1 plus 2 times 2 gives you 3. Continue the process and find the rest of the entries. But you get the exact same matrix by multiplying these three different matrices. AC is equal to BC, right? But A and B are not the same and C is not 0. So in general, when you learn in algebra that 2x, for example, is equal to 2y, you can easily conclude that if x is equal to y, it's not correct in algebra of matrices. So I highly encourage you to memorize some of these examples. They usually are on the exam. We usually ask students come up with examples to contradict some of the statements. So these are good examples.